The tides. The Earth attracts the Moon to keep it in orbit. A force of gravity is exerted by the Earth on the Moon. According to Newton's third law of motion, the Moon exerts the same amount of force on the Earth. Of course, the Moon is less massive than the Earth and farther away than you are on the surface of the Earth. Nevertheless, the Moon's gravity measurably affects the Earth. The side of the Earth facing the Moon is about 6,400 kilometers nearer to the Moon than the center of the Earth. Thus, the force of gravity of the Moon on this side is stronger. Since the Earth is not perfectly rigid, the force of gravity of the Moon causes the rocky surfaces, mountains and plains to bulge up a few centimeters high. Seawater is fluid and thus can respond more to the weak force of the Moon's gravity. It flows into a bulge on the side of the Earth facing the Moon, thus causing what is known as a tide. Actually, there are always two seawater bulges on opposite sides of the Earth. These bulges are caused by the motion of the Earth-Moon system. Although it is said that the Moon orbits the Earth, both actually orbit a point known as a center of gravity. Since the Earth is 81.3 times more massive than the Moon, the center of gravity is 4,700 kilometers from the center of the Earth. The Moon therefore moves in a large orbit around the center of gravity, while the Earth moves only slightly. This causes seawater on the far side to flow into a bulge. Since there are bulges on opposite sides of the Earth, you observe that tides rise and fall twice per day. Because of a similar reason, the Sun also produces tides on Earth. At new moon and full moon, the Moon and the Sun produce tidal bulges that add together, producing an extreme tidal change. In this case, the high tide is very high and the low tide is very low. Such tides are called spring tides. At first and third quarter moon, the Moon and the Sun pull at right angles to each other. In this case, the tides do not add together and therefore are less extreme. Tidal forces cause friction between the ocean waters and ocean beds. This slows the rotation of the Earth by 1 times 10 to the power of -3 seconds per day per century. Thus, 400 million years ago, the day was only 22 hours long. Similarly, the Earth's gravity causes friction within the flexing rocks of the Moon. This slows down the Moon's rotation, such that today the Moon keeps the same phase toward the Earth. Tidal forces also affect orbital motion. Friction within the solid portion of the Earth drags the tidal bulges eastward ahead of the Earth-Moon line. These bulges pull the Moon forward in its orbit. In effect, the Moon's orbit grows larger. As a result, the Moon recedes from the Earth at about 3 centimeters per year.